Welcome everyone to today's webinar from CrateIO. Today we're going to be talking about fixing data silos in a high-speed logistics environment. I'm Jan Weber, I'm a product manager at CrateIO, and I'm looking after CrateDB, our main database product. And I'm joined today by Alexander Mann from TGW, who is our domain expert when it comes to the data challenges in logistics. Welcome, Alexander.
Hello, thanks for having me. Hi. I'm Alexander Mann. I'm from TGW Logistics Group. I've been working in various positions of software development over the last 20 years. And in the last 2 years, I was focusing on how we can help customers with additional services, digital services based on data that we can get from our sites.
Thank you, Alexander. So what are we going to talk about today? So I will be starting off with a little introduction into CrateDB and CrateIO, the company behind CrateDB. Then Alexander is going to give us an introduction to TGW Logistics. We're then going to dive into the success story, into the challenges that they faced. We'll then look a little bit more at the product from scaling CrateDB clusters and schema creation and indexing. And we're going to end today's webinar with a Q&A session. So we will be addressing questions at the end of the webinar. Please feel free to, at any point in time, use the Q&A function in Zoom to send us any questions you might have. And also, please feel free to share in the chat with everyone where you're coming from. I'm sitting today in my home office in Karlsruhe, so please let us know where you're coming from. So as mentioned, let's start with an introduction to CrateDB. So CrateIO, the company behind the open source database CrateDB, was founded in June 2013. We have over 60 employees worldwide with office locations in the US, Germany, Austria, and Switzerland. We're a VC and industrial investor funded startup. We're available on all of the major cloud platforms with partners in the industry and quite some awards and recognitions in the past. Besides our database product, also in 2021, we launched our CrateOM solution, a solution for smart manufacturing that actually utilizes CrateDB in its solution. I mentioned already our core solution is the database. Our database is open source, enterprise grade database for digital use cases, a building block for all of your analytics and AI and data science use cases. We're optimized for large data volumes, high volume of compute, complex queries, versatile data. We're easily scalable, both on-premise and in the cloud and in the edge, and all with a familiar SQL interface. And we can store basically any type of data, whether that's structured, semi-structured, time series data, geospatial data. We have a shared nothing distributed query engine that allows you to run all of this at scale and high available, as we will also see in the future. And our solution is available on everywhere you want to run it. Basically, we have our CrateDB cloud offering, which is a classic database as a service offering, worry-free. We take care of hosting and operating your database. You just use your database. If you have your own environment, there's CrateDB Edge, which is bring your own Kubernetes environment, basically. So you can provide the Kubernetes environment. We provide our database as a service on top of your infrastructure. So it's kind of a CrateDB light, so to speak. But you can also run CrateDB on any of your physical hardware or in a Docker container with our open source version, which is Apache 2 licensed. Benefits of cloud and edge specifically are the quick and easy way to get started, easy way to scale it, and built-in backup and recovery functionality. And with this, I'm going to hand it over to Alexander to talk about TGW Logistics.
Thank you. So TGW Logistics is a system integrator of automated warehouse solutions headquartered in Machtrenk, Austria. You can see our beautiful building here in this picture. What we do is we design, manufacture, implement, and maintain highly automated and efficient end-to-end solutions for fulfillment centers. So we're supporting everything that's going on between the four walls of the warehouse, from the goods receipt to storage to packing, picking, shipping, all those core processes. And our scope covers designing the systems, manufacturing the systems, installing the equipment, developing, configuring, and customizing the controls and the logistics software, and maintaining the system during its lifetime. And TGW is a foundation-owned company, so the TGW Future Private Foundation has a focus on people and learning and growing. So we have a lot of social projects going on where we empower young people to pursue their own personal development goals. So we have over more than 4,000 employees in 25 locations all over the world, roughly $1 billion revenue this last fiscal years, and we are located in a lot of locations in Europe, in the United States, and also in China. So TGW originally started out being a mechanical engineering manufacturing company, and today we're a technology company with a strong focus on software products for intralogistics, with the goal to really provide fully autonomous, self-learning, self-healing systems of the future that customers can operate in a dark warehouse. And to realize this vision, it's really important to learn as much how our warehouses work, how they are operated on a machine and process level. And that is what I'm going to talk about.
All right, thanks, Alexander, for this introduction. So what have been the challenges in your use case that you've discovered?
Yeah, so automated warehouses are really complex systems. They consist of various components. So there are storage solutions like shuttle systems or mini load cranes that operates in the racks. We have different kind of workstations for decanting, order picking and packing, and they're either manually operated or by robots. Each warehouse has a lot of kilometers of spanning conveyor systems where we have to connect the different places in the warehouse, and we do that either with conveyors or with autonomous robots. And lastly, we have a lot of control software and material flow software, warehouse management software that manages the transport and the logistic processes of that warehouse. And when you look at that system, you see that there are a lot of different challenges you can face. So the first one is we have a lot of different data sources. As I explained before, there are S7 PLCs, there are embedded controllers, webcams, energy measurement devices, all kinds of sensors, as well as our software systems and various third-party software systems we have in our projects. They all have data in various data structures. Okay. Can you still see the screen?
Yes.
It breaks up a little bit here. All right, so with different structure and formats, machine data is stored in various registers on the PLC. There's binary data like images, files, webcam streams. There are tables in relational databases or events on a message bus. And there are various ways to access this, polling a PLC with Modbus, with S7 protocol. There's recurring database queries, REST APIs, web service, and all of that with a really high volume. We have warehouses with 200 conveyor systems, 40 shuttle aisles, 60 pick centers, and we move 30,000 to 6,000 load carriers an hour. So this triggers a lot of data points. And we have to ask ourselves the question, how can we collect, process, and store all of that data on one hand, and how can we make this available to our staff and to our customers? And this is where we started to investigate IoT platform, cloud platforms, new modern databases that are able to work with this data. And that's how we found CrateDB.
So when it comes to the things that you discovered, one of the things is managing the data, unstructured data, structured data, raw data, a lot of data everywhere. How did you approach this? What did you use? How did you get it to a solution with all of that large amount of data?
So what we started off was fetching the data, I would say, in its original form. So without trying to aggregate, condense, convert, or simplify it. And once you have it in your data store in that form, then people can start analyzing it, analyzing the structure, and learn what they want to do with it. Because before that, you don't know what to do. So it's this usual dilemma you have with data. Before you have the data, you don't know what to do. And once you have it, you don't have the data you need. So that's why we decided to get as much data as possible in its original form. And that is how we got the data in. And CrateDB supports this very well by having the ability to directly store JSON objects in the database. That speeds up this process a lot, and it creates a dynamic schema out of those objects. So these virtual columns that you can use, and this also works for nested data structures. So that helped a lot. And once we got all the data in, we were able to look at it, take the data we need, create a data catalog with all the definitions. And out of that, we were able to create schemas that we can apply on the columns of CrateDB that then enforce the schemas. Again, so that is really a big advantage of using CrateDB in that area and helped us a lot.
All right, so you put everything, all data into CrateDB, and you selected the data that you want. Now, that was your first part in creating a data catalog and everything, and now you've figured out the data that you want and the schema that you want to enforce. And how did you go about changing the way you collect the data? Did you continue to collect all of the data? How did you get to involving also what data is necessary in order to be stored and what delivers your value?
This is where our domain experts came in. So the people that are experts on the machines, on the mechatronic equipment, on the logistic processes from a design perspective and the software perspective. And there we faced another challenge because a mechatronic and automation expert in the beginning, they know what data they need, but they are no experts on software or data science and data collection and protocols. So that was the next challenge that we had to build a system where we can help these people to do what they need to define the data on their own and to define the data collection on their own and to provide an easy mechanism to get this data. And that is where we introduced pipelines. So basically, each domain expert, each person that wants to use this can create his own data collection right away and reuse existing templates. If you ask now the question, okay, what can CrateDB do about this? Honestly, I have to say CrateDB in this context couldn't help a lot, but it helped to keep our backs clear because we didn't have to look at how can we set up a cloud-based database, how can we operate this, how can we scale it out, and the people at Crate helped us a lot, and the customer success team to get this going and to continuously keep it running and providing all these web-based tools where you can have full control over your database, even though it's operated by Crate.
Great. So we have captured the data. We have the data catalog. We've identified what we want. We have our domain expert that provided us insights into creating our pipelines. CrateDB enabled you to get to the data catalog, kept your bags free in terms of getting to the domain experts and being there to run and to scale as the amount of data grew. But we're still at a point where all of your data is in the database. So you still want to do something. How did you go about accessing the data, about getting the business value out of the data that you collected? And what did CrateDB help you with that?
Yeah, so you're absolutely right. Looking at database tables is probably interesting for developers, but if you are an expert on your domain, you want to have this data in a different form and have access to this data in a different way. And what these people want to do, they want to use their known products for data visualization. They want to be able to query the data in a good way, in an easy way, and also people that develop stuff on top of the data, they want to use their existing frameworks, their existing technologies right away. And so the ability of CrateDB to use a standard SQL on a large volume of data opens really an entire range of data visualization products like Power BI or Grafana, or there are a lot of others, you name it. So we were able to quickly prototype the screens and the dashboards that we wanna have, and people are able to even create those dashboards on their own. And based on that, we were able to have a more accessible and easier user interface with predefined dashboards where everything is ready for the staff in the warehouse that really wants to operate the warehouse and maintain and just get insights of the data, and not having to write queries or look at creating dashboards on their own. So, and here we had the big advantage that by CrateDB having standard SQL, we could use a lot of existing frameworks and leverage the power of the tooling that we already have in our development stack and in our technology stack.
All right, so we basically have now the full picture. We collected the data thanks to flexible schemas. We were flexible enough to ingest the data. We've consolidated it with our domain expert, built our pipelines, scaled our clusters, integrated our visualization tools, and we delivered the value that we wanted to for the business in order to have everyone outfitted with the right data at the right time. But are there any other final observations, anything along the lines that you stumbled over that you want to share with our audience?
Yes, so on that journey, of course, we didn't immediately find CrateDB. So we had to try out different things before. So it was very obvious that we really need to go to a time series database. That was pretty obvious. So we took an open source, another open source product before that, and it had a proprietary query language. So it was really hard to use tools, and a lot of people were not able to use this. And also there was not the ability to store these hierarchical data structures right away. So we had to think a lot in the beginning, and we only did this for a few use cases. So that's why it wasn't that much of a problem. But flattening out the data and thinking of a data model first really slows you down in that process. And we also tried a NoSQL database because of having this, let's say, unstructured data, unknown data before. And again, we had a proprietary query language that with the same problems that I just quoted. And also the scaling and the installation of the database required a lot of upfront configuration of nodes and replication and sharding. So we had a rather steep, rather long learning curve until we were able to get data in and out. And back then, this solution also didn't provide anything in the cloud like database as a service. So we would have had to figure that out as well. So Crate has really given a lot of thought in their product to solve those specific needs that you have when it comes to ingesting data, storing data, analyzing a huge amount of data. And so if I say a recommendation is, if you have this topic and you want to learn about data, then try to go on, give CrateDB a try and look at it. I hand back to you, Jan.
All right, thanks a lot, Alexander. We'll get back to you in the Q&A session, I'm pretty sure, but this was some exciting insights. And I want to go a little bit deeper into some of the topics that you mentioned. You mentioned SQL as a universal query language, something that we do, but also the scalability approach of CrateDB is one of the key strengths and the easy scalability. Now, if we look at cloud, there's of course always an easy scalability. Much of it is handled as a database as a service, but CrateDB in general had scalability built into its design. We have our shared nothing architecture, which really means that each node in a CrateDB cluster can perform all of the tasks that are needed in the database. So you can talk to any node in your cluster and you will get query results. We also have, of course, sharding, replication, all of those concepts in place, but we take care of it in an automatic fashion. We distribute the shards across the cluster so that you have the best replication possible for your configured needs. You can always, of course, also change this. Our distributed query engine allows you to distribute the queries across the cluster so you get always the best performance out of it. But you can, of course, also still use an external load balancer, as you can talk to any of our nodes. You don't have an access node or anything like that. That also means that you don't have a single point of failure with the CrateDB cluster. With everything replicated, a node can simply fail. And of course, also scaling up becomes much, much easier when we talk about a shared nothing architecture. You don't need to worry about which role a node will play in the cluster or how to get data to it, how to distribute your shards, your replica sets across that cluster. That's all taken care of by CrateDB itself. So you can just add a node and it will automatically completely rebalance itself, and you get that additional performance and storage into your cluster. That means you can really start off with a single node on the edge, on premise, wherever you are. You can then build this out into a multi-node cluster. We always recommend that you go with at least 3 nodes for high availability and performance reasons, but you basically, with the shared nothing architecture, can get an unlimited scalability. You can scale to hundreds of nodes without any challenges because we really distribute and leverage the full capacity of each node. And all of that, of course, gets much easier even when we talk about CrateDB Cloud, where all of this is available at the click of a button. Now, we also talked specifically, or Alexander talked about the challenge of getting the data in and getting a feeling for the amount of data and the structure of data, and also fast query results, search results. So one of the things that I want to talk about is also schema creation, schemas in general, and indexing. And one of the things that we do in terms of indexing with CrateDB is in CrateDB, everything is an index. So that allows us to really have fast search results and super fast aggregations. If you look at this example for texts, for fast searches, for everything, we create a full text index, so a reference for each entry, plus the IDs of the records in either a full text index or for numerical values in a BKD tree. That allows us to really do fast searches for things. So if you're looking for something specific, CrateDB will give you really, really fast results. But also when we talk about document values, we have a columnar store where we really store all of the values for super fast aggregations, so you can get also complex aggregations done in a real quick way to really get to the insights that you want in a quick way. And the benefit of everything being an index with CrateDB, if you start out, you don't need to decide what am I likely going to be querying, what will I need to get fast search results, what indexes do I want to build. Everything will be indexed. But of course, if you know I will never use that, or I'm going to be willing to take a performance hit on it, you can of course also disable indexing for specific columns or for specific values at any point in time in your configuration. The other thing is dynamic schemas. So in general, in CrateDB, our schema is flexible. Our schema is flexible and it's implicitly created by just creating a table. But you can, of course, also enforce a schema. But the flexibility of the schema is a great way if you're still trying to discover data, or if you have data coming from a third-party data source that you don't have full control over, where you don't know if that data type or the data that you will receive might change over time. So you can either enforce that schema so that if data is tried to be inserted that doesn't fit the schema, there will be an error, or the schema will actually be automatically updated by adding new columns and also indexing them, or getting JSON data in there. And in particular, if we talk about JSON data, we have our object dynamic type where you really get the full flexibility. If you get, in this example, also a JSON from a machine, if you don't know what the JSON format is going to look like in the next firmware update of that machine or in the next generation of that machine that you're building into your environment, you don't need to worry about that, because you can still use a dynamic schema. We will still store it. Yes, you might need to apply or change your queries to get that information that is submitted in addition, but you don't need to worry about your database schema. You don't need to manually interact with it in order to avoid errors in that. And our JSON object support includes full nested object support. So an object can include an array or additional objects that can include additional objects. So it's really flexible with a dynamic schema, how to handle evolving data structures, how to handle changing data structures, whether that's in a discovery phase of what data is actually existing, or further down the line if something changes while you're operating your database. So with this, if you want to learn more about TGW, Alexander, where can we go and learn more?
So there is our website with a special microsite focusing on our digital services, but I think there's also a lot to find out if you're interested in logistics or just want to look what's going on in this part of the domain. Please visit our website and look at the things there. There are also all the contacts there, how to get in touch with us.
All right, thank you. If you want to learn more about the success story beyond what you've heard today from Alexander around the TGW Logistics success story, or beyond the Q&A that we're going to start in a minute, feel free to drop by the crate.io website and check out the success story that we've created together with TGW Logistics. And with this, we can start the Q&A. So we already have a few questions, Alexander. I'm just going to read them out to you, and I think most of them are actually at the moment for you to answer best. So what was the biggest challenge in implementing CrateDB for TGW Logistics?
I would say understanding some of the internals of CrateDB, because like I mentioned before, it looks and behaves like a relational database, but from a technology point of view, of course, it isn't underneath. So learning how to configure the tables to get the most out of this replication, about partitioning, about the dynamic schemas, and also learning the limitations that are there, because every technology has limitations. That was one of the challenges. The team at Crate helped us really well in getting those answers out for those questions, either with the very fast responses on the Jira board, and also we had a lot of meetings and online sessions to really cover design and architecture.
All right, great. And I think related to that, how long was your migration process? I'm assuming that's from whatever was there existed before to the CrateDB solution.
Yeah, so as I mentioned before, we tried some solutions, but those we all tried, let's say, in a phase where we worked with prototypes. So we didn't really have the challenge of migrating a lot of data from there. Basically, we migrated no data at all. If the question targets migrating technology-wise, that worked really fast because of this previously mentioned capability of using SQL and all the web interfaces. So I would say we were ready to go in a month roughly with all the things. We started with a local installation first, following the guides on the website. Like you mentioned before, this Apache version, and later on, then we decided to go for a database as a service. So it was really fast switching to CrateDB and adopting the technology.
Great. So next question, again for you, Alexander, is how long has TGW been using CrateDB?
So I would say we're in about two and a half years now with the first attempts and the first prototypes, and about a year we have sites in production where we get data and work with the data and display the data for the customer.
All right, great. And a last question so far, what are the lessons learned to achieve best performance on your end?
Yeah, so I would now say if we're talking about, let's say, the database performance, this worked pretty well. Also, again, with the service engineers from Crate, that I sometimes have the feeling there is a person sitting in front of the console and always watching if the thing goes well. And I think also with the query performance and everything, we didn't face any problems so far. When we're talking about logistic performance and performance of the sites, which is, of course, the important business goal that we are targeting with all these activities. We have already seen that we learned much better how customers operate our sites, how they use our equipment, and we're already able to get a lot of information out that we couldn't before, because it was a lot of effort to get this data from all those different data silos. And with CrateDB, we all have it in one place, in one format that people can query and can understand from a domain language. So this sped up a lot how we learn about our sites and learn from the data they are producing.
All right, great. Thanks a lot, Alexander. And if you have any more questions, feel free to type them in the Q&A section now. And if not, as we mentioned already, feel free to check out TGW's website to learn more about TGW Logistics and also their technology side of things. Feel free to check out Crate.io to get access to the success story, but also feel free to try out CrateDB Cloud, all easily accessible on crate.io. And if you have any other questions that you want to follow up with us, you can reach us via email at the addresses that you can see on the screen.